Are you a maker who wants to live stream your electronics work, but doing it at your computer just isn't working out? Have you wanted to record a tutorial, but you don't know how to do so at your workbench? If so, this is the video for you. I've been dreaming about setting up my own electronic streaming and recording workstation for years. My friends at Elgato were kind enough to send me some goodies to make this possible. A couple of which we'll use in some non-traditional ways. A workbench setup is personal, and your needs might be different from mine. But I hope that this can serve as a guide to get you started on building your own ultimate streaming and maker workspace. Let's do this. Let's build this from the ground up. First, storage drawers for my tools. You can never have enough storage. Since I do a lot of microcontroller programming work, and for streaming, I need a computer. I'm using my machine from 2021 as it doesn't need to be super powerful. Throw a monitor up on the shelf and add some more storage for electronic components. A high-temp project mat is useful to keep from burning the desktop, especially when using our soldering iron. And to assist soldering, a quality helping hands is a must-have. A benchtop power supply is necessary to power our projects. And I find many uses for both my oscilloscope and a logic analyzer for the types of projects I do. A few details on some of the tools chosen that integrate well with streaming. The oscilloscope I use, a Siglent 1104XE, is a great scope for electronics work. It has a solid sampling rate, 4 channels, and specifically for streaming, it provides a web interface to display what's on the screen in a browser. This can then easily be brought into OBS. Dollar for dollar, it's a solid scope for getting into electronics work. As I do quite a bit of hacking on existing electronics, a logic analyzer is one of my most used tools. I chose the DreamSource Lab DS Logic Plus, which is a USB device that uses Windows software. It has 16 channels, an adequate sampling rate, and again, due to its USB interface, its output can be shown quite easily in OBS. One final tool that I didn't mention is probably one of the most important for doing electronics work: a multimeter. Unfortunately, benchtop multimeters with capturable output are quite expensive. Thus, I primarily use this fairly inexpensive meter, which has all of the multimeter features I need, and a large screen that can easily be seen in OBS with the top-down camera we're going to set up later. I'll leave links to all of the tools I use in the description below. Before we move on to the streaming setup, I'll also mention that there are a few other larger tools I use that are not seen here. Specifically, a more fine-tip soldering iron, a hot air rework station, and a hot plate for SMD work. Due to my space constraints and the fact that I don't use them as often as my other tools, I have these stored away and bring them out as needed. Additionally, I have quite a few small hand tools such as cutters, screwdrivers, and solder removal tools that I store in the 6-drawer unit under the desktop. Now that we've set up our workbench, let's make it a great spot to stream. The first issue we have is dim lighting. Let's fix that by adding a couple of Elgato key lights. There, that looks a lot better. I love how the key lights can easily be controlled from my computer or Stream Deck, and everything can be automated to make streaming easier. Just as important as lighting is good sound. After all, how are you going to teach your audience what you're doing if they can't hear you? So let's add a microphone with a low profile mic arm. I prefer the low profile arm as bringing it in from the side keeps it from blocking my view of the project space, and when I'm not streaming, I can easily swing it out of the way. I like to stream with a face cam, hence the focus on lighting, and so now we'll add a camera, in this case, a Facecam 4K. Now we have a solid recording and live streaming setup, but what can we do to elevate our presentation of electronics work? How about the ability for some tight shots of what we're working on? One option is the non-traditional use of a mic arm to hold a camera. In my case, an old iPhone 11. The mic arm provides flexibility. We can get the camera nice and close, or move it up for some wider shots. And again, we can swivel it out of our way when we're not streaming. Speaking of lighting, let's add a movable subject light. This will help for those very close-in shots and even help with lighting things up off-stream when working on smaller components. Here, I'm using the compact Keylight Neo on a Wave desk stand. I can slide it around and bring it in to provide lighting for close-ups. Finally, we need to have easy control of our streaming or recording software, and a Stream Deck is a fantastic option. Now, I'm totally spoiled and happen to have a Stream Deck Studio, which as you can see, has the perfect form factor for my setup. That said, the Studio is 100% overkill, and a normal Stream Deck would be a more sensible choice. Can I really post a video without doing something in OBS? No, I don't think I can. So let's walk through setting up a couple of basic OBS scenes to both live stream and record our work. We'll be building this in a fresh copy of OBS that has the Move plugin installed. I'll leave a link to the plugin in the description below. We'll start by setting up a basic talking scene with our face cam full screen. I'll be sending my output from this machine to my main streaming rig, which will handle all of my overlays, so we can keep the design of this scene collection simple. Bring in your video capture device and make it full screen. Also, make sure your microphone is being used in this scene so that you can be heard. In under a minute, we now have a talking scene that we can easily switch to. Next, let's create a scene to show our electronics work. To this new scene, add another video device, this time your movable camera. I'm using a software called OBS.camera to bring in a high-quality feed from my iPhone, but you can use whatever camera and interface you have available. This is what your viewers will be most interested in, so make it full screen. Now, go ahead and add the same face cam source from your other scene, and resize it to be down in the corner. If we then select Move for our transition and adjust the settings to our liking, we have a beautiful animated transition between our two scenes. As you can see, we now have a basic setup for showing off our electronics work and chatting. But what about that oscilloscope? As I mentioned, the scope provides a web browser interface that can be used to project the screen. So let's go ahead and add an OBS browser source. First, I'll enter the scope's web address in the URL field and adjust the source size to 900 pixels wide by 600 pixels tall, which almost perfectly fits the video. And look here, we have our oscilloscope output directly in OBS. Let's shrink this down and put it above my face cam. Now we'll get fancy. Let's make the scope expand when we want to focus on it. To do this, we'll use the Move Source filter. Right-click the Workbench scene and select Filters. Add a new Move Source filter and call it Small Scope. Now select our oscilloscope preview as the source. Scroll down and set the custom duration to 500 milliseconds, then click the Get Transform button. Now, duplicate the filter we just created and call the new one Large Scope. Next, drag the source to where you want it when large and resize it. Back in our scene filters, select the Large Scope filter and click the Get Transform button to get the new large size. Now, we can click one or the other filter to grow or shrink our scope source. Finally, let's make a toggleable action that we can use on our Stream Deck. Again, in the scene filter list, add a new Move Action filter and call it Enlarged Scope. For our start action, we want Filter Enable. Select our Workbench scene as the source and select the Large Scope filter. For the delay, select Infinite. To finish it off, our end action will be our Small Scope filter on our scene. Now we can toggle this filter off and on to call out our scope. Let's quickly take it to the next level by adding some buttons to our Stream Deck. Open the Stream Deck software, and we'll start by adding a button for each of our two scenes, Talking and Workbench. Now, let's add the ability to completely turn off or on the scope source. Add a source visibility action, select our Workbench scene and our scope source. Voila! Now we can turn our scope off or on. The final button we will add is to enlarge or shrink our scope. Add a filter action, select our Workbench scene, and finally the Enlarge Scope filter. And there we have it, a button on our Stream Deck that can grow or shrink our scope source. Now we have all the basics for streaming electronics. Feel free to expand on this. Perhaps add your logic analyzer software, other cameras, etc. The sky really is the limit. If you made it this far, I hope you found this video useful. I'd love to add on to this setup, things like a soldering microscope and additional cameras, but that'll be for another time. I'll see you all in the next one. Oh yeah, like, comment, and subscribe!